Hello, let's continue our Sudoku adventure with Diversity by SennyK. So we have normal 6x6 Sudoku rules. That means in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have these white dots in the grid. Digits separated by white dot must be consecutive. So if this is 2, this is a 1, so they're consecutive, or this is a 3, also consecutive. Now, not all the white dots are given, meaning if in the solution this was 2 and 3, we could have given you a white dot, and we chose not to, and that's fine. We are not giving you all of them, just some of them. But we might have given you all of them. That's why it's not all dots are necessarily given. We don't want you to imply that, hey, all of them are given, so, or not all of them are given, so I better have like a 2, 3 somewhere. Anyway, that's not it. It's just these dots do it. No global constraint. It kind of looks like a T-Rex. Anyway, we also have global entropy. Very important to remember this. Every single 2x2 in the entire grid, all of the overlapping 2x2s, every single one of them has at least one of each of a low, medium, and high digit. Low being 1, 2, medium being 3, 4, high being 5, 6. So this could be like 2, 3, 6. And so that's our low, that's our medium, that's our high for this 2x2. This could be anything. It could be a 5, it could be a 4. It's gonna be a repeat, obviously, because we only have 3 groups. But there's only gonna be one repeat. Anyway, you must have at least one of each. And so then this also has one of each. This also has one of each. Builds out. All right, and that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. Okay, so I'm going to mark this blue. I'm going to use blue for low, purple for medium, and orange for high. That's the colors I'm used to. I want to start by thinking about these white dots because there's really nothing else to think about. So there is one other thing I want to talk about before we do that, which is something we want to keep in mind the whole time, which is global entropy interacts with these 2x3 boxes in an interesting way. This is just something I realized while thinking about the constraint. So we can't ever have 2 of the same low, high color. Like let's say these were both blue. What that would mean is this 2x2 didn't have a blue in it, right? So that's not allowed. So these extreme stripes, all of these, can't ever have a same color within the box. You can do it here because this can have blues, this can have blues. In fact, it always does. And so that works out just fine. But we can't do it here because then the rest of the box doesn't get it. So that's something to think about. But otherwise, I mean, there's not much we can do in this grid right now. But I want to think about these white dots, especially this chain here, this chain of 4 white dots. So it's going to be either 1, 2, 3, 4, 2, 3, 4, 5, or 3, 4, 5, 6. Meaning, if you think about it, the digits we're missing are always extreme. So this is missing 5, 6. This is missing 1, 6. This is missing 1, 2. We're missing 2 extreme digits in order for these to be consecutive. They have to be a consecutive chain because it's all in the same box. We can't repeat, which means we can't backtrack. So notice we're only missing 1, 2, 5, or 6. That can't be 1. And that does mean this one can't be 2, because if this was 2, we'd have to be the 1, 2 case, but that can't be 1. So like if this is 2, we have nowhere to put 1 here. So this one's not 2. I'm sure that's super important. All right, so let's think about this then. It's going to have a 3 and a 4 on it. And this isn't going to be 1, 2. Right, because we said this vertical can't do that. And so we can't start with 1. If we started with 2, we'd go 3, 4, 5. That seems okay. If we started with 3, then we'd do 3, 4. That's also not allowed. So I can't do 3. If we did 4, notice we can't go 4, 5, 6, because then we don't have something else to put here. So 4 would go back down to 3. That's also not allowed. And then 5 would go down to 4, 3, 2. And then 6 was no good because it would go down to 5. So because these two can't be the same color. So that means these are both purple. And so that's a 2, 5 pair. So this is a 1, 6 pair, making that 1, that's 6. That's blue. That's orange. These two can't be blue, both. So that has to be 5, and that's 2. All right, so that's orange, and that's blue. Okay. 2 can't be next to 1, so it's next to a 3. That's purple. Here, oh, we know what these are. Sorry, that's 4, that's 3. So 4 is next to 3 or 5, I guess. Oh, but this 2 by 2 can't have another 3, 4 because it's already got 2 purples. We need one of each of the others. So that's 5, and then this has to be blue, so that's 1. All right. This 2 by 2 needs a blue. All right, so this is 1, 2, 5. This is 3, 4, 6. This can't be 4 or 6. This is our 3. It's purple. So this is a 4, 6 pair. And this is known. This is a 2. That's blue. And this is okay. It's just the sides that can't be the same. Are there any 2 by 2s to think about? This 2 by 2 needs an orange. So that's 6. So this is a 1, 2 pair. Those are both blue. And this is a 4, 5 pair. This is from 3, 4, 6. This can't be 3 or 6. So that's a 4, making it purple. And this is a 3, 6. So this can't be a 5 because, again, oh no, sorry, it can't be a 3. Never mind. I got my mediums confused. Do we have any more dangers of doing this? Like, this isn't a 5, 6 pair. This column is 1, 2, 5. That's not 2, that's not 1. This can't be a 1, 2. So this is the other 1, 2, and it's blue. Now we need a high here, so that makes that 6 and that 4. 4 is purple. You need a high here, so that's a 6. And this column finishes with a 3, which is purple. And so this is a 2, 5. Oop, not 2, 5. 4, 5 pair. This needs a medium. This can't be medium, so this one is. It's a 4. That makes that a 5, which is orange. So that's 2 and 1 and no, sorry, 2 and 5 and 1. So this is blue and this is orange. These aren't 1s. All right. Let's just fill these pairs. This is a 4, 6 pair, and this is a 1, 3 pair. All right. So I think we're gonna have to think about this a little bit. Is there a 2 by 2 that's useful? I mean, one of these has to be purple, but we have both 3 and 4. One of these has to be high. We have both 5 and 6. What am I missing? Is there just like a pair or something that I didn't get? 1, 3, 4, 6. Like I don't know that there's a 2 by 2 that's in too much danger here. Maybe I'm just not seeing it. Like, I don't think it's going to be these. These don't really have a choice of what numbers are there, so they better be right. So it's got to be these. Maybe here or here. We need a purple. Yeah, and 2 and 5 are both not purple. So this needs to be purple, and it's a 3. Okay, that was sneaky. That's a 1, which is blue. And I'll just finish the digits, and then afterwards I'll color them. That'll be a little faster. All right, nice. So 5s and 6s are orange, and then the 2 is blue, and the 3s and 4s are purple. All right, cool. Nice puzzle, Senny. Yeah, the global entropy is very powerful, especially in 6x6. I like how you used the fact that these couldn't be the same, and I'm glad I thought about the constraint a little bit first before solving. All right, cool. Well, how'd you do?